Hi, I'm Kerry Hartwig with Sukup Manufacturing Company, and I'm the dryer sales director. Today we're at a tower dryer. We're going to take a look at the pipe train and how the fuel gets into the burner. So we're going to start here. This is a drip or oil or water drain. This dryer happens to be a propane dryer, so they can have oil in them. This cap should probably be removed once a year just to remove any accumulation that could build up in there. The next thing is just a quarter turn shutoff valve. And if the handle is up or perpendicular to the line, that means it's off. If you turn it down parallel, it's on. Obviously, you want it off in the off season. The next thing is called a Y strainer. It's blue component here. The Y strainer, the bottom part actually can come out, and there's a screen inside there that should be checked and cleaned once a year. Anything that could accumulate, such as metal filings or shavings, could accumulate in that screen, and that should be checked yearly as well. The next thing that we come to in the pipe train is a T and a small line that comes up to a regulator and two solenoid valves. This is the pilot circuit. So the pilot regulator is basically factory set. You shouldn't have to adjust that. And then has two ASCO solenoid valves, just on-off valves. And then there's a copper line that goes from here and it just goes all the way up into the burner. If you do have troubles getting a pilot line to light, sometimes you'd have to take this loose and actually blow pressurized air up through there. It is possible that water could get in the copper lines and have to be blown out potentially. The next item here, we call this the Siemens solenoid valve block, and that has many components in it, so we'll take a look at what all of them are. The first thing we come to is a low pressure switch, and this just indicates that we have enough gas pressure to run the dryer. And this dial here will be set between 40 and 200 inches of water column. The low pressure switch should be set at 40 inches of water column. There is an indicator light on here, so when main power is on and we have adequate gas pressure, the light will be on. If the light's off, then we might have not enough fuel. Maybe the quarter turn shutoff valve hasn't been turned on, something along those lines. There's also an incoming pressure gauge here. The gauge will read in PSI, or pounds per square inch. We want to see 6 to 9 PSI on this gauge of incoming fuel pressure, whether it's propane or natural gas, either one. Then there are two basically solenoid valves or safety shutoff valves in the valve block. And the first one is simply an on-off valve. They're an electric over hydraulic type of a valve, so there is hydraulic fluid in them. And you'll see an orange heater strip that's on them. That's just to keep that hydraulic fluid warm enough to flow when it's below freezing or very cold outside. The first one is that. On the back side, you'll see a proof of closure switch. As part of the safety circuit, the burner controller needs proof that that valve is actually closed, so we know we're not putting raw gas up there before it starts. The second safety valve is actually a valve with a regulator built into it. And the regulator is actually the control regulator that controls how much pressure goes up to the burner. So if dual purpose, the valve is on-off, just a second safety valve in line. And then the pressure regulator, which can be adjusted by removing this cap here, and then you have a typical flathead adjustment in there. That regulator is set to determine what the control gas pressure is downstream. And that would actually be set at 40 inches of water column with the butterfly valve wide open. We'll look at that when we see the butterfly valve. Next thing is going to be this high pressure gas switch. So this will be very similar to essentially the same thing as the low pressure gas switch. It's just set at a different number. That one will be set at 200 inches of water column. That would be on the discharge or on the outgoing end of the Siemens valve block. Okay, then after the Siemens solenoid valve block, we have a quarter turn shutoff valve, red one here. And again, if the handle is perpendicular, it's off. If it's parallel, it's on. So off in the off season, on when you're running. And then the final main component is a butterfly valve. So this valve here is inside here's a butterfly valve like a carburetor. That controls how much fuel goes up to the burner. And the black thing on top of it is an actuator motor. So that opens and closes that butterfly valve. These can be a little bit fragile. If water was to get in the system or allowed to be in the system and freeze, one of the first things that could have a problem is this butterfly valve. And there's an indicator here showing its position from 0 basically to 90 degrees, you'll see on there. There's also another indicator on the top of the actuator motor, and you can take this cover off. If you suspect there's a problem with the motor, the cover will come off, and there's actually a manual and automatic. You can turn it to manual and manually open and close that valve just to make sure that the motor works and that the valve is free and turns. The next thing you've got is another pressure gauge. Now this one is in inches of water column, so this is the control pressure downstream. And I mentioned the control regulator. With the butterfly valve wide open, we want to see 40 inches of water column on this gauge. Typically we're going to run at much less than that, but max would be 40, and that would be our set point. From there we come to a T. On the bottom of the T, there's a quarter turn shutoff valve here. And this is very important. This is just a drain valve. So the heater is pointing up and it's kind of like a funnel. So in the off season, water can get in it, or we can have condensation on the long steel pipe. And we want to wait for that water to get out so it doesn't come and destroy the components like the butterfly valve or other components upstream. So in the off season, this valve needs to be open. When you're running the dryer, of course, you want to close that so we don't have a gas leak going up. And then you can see the copper line here, along with the big line. This goes up to the burner itself. So now we're at the discharge moisture sensor, and this is what we call a static moisture sensor. So let's take a look at how that works. The sensor itself is the green block here, and to get it out, you would remove the clasp, open it, and take it out. And in the off season, this just has a quick disconnect. So I do recommend not storing this on the dryer. It's best to take it inside in the off season. There is a circuit board inside here. Before it's installed, you want to clean, this one's pretty dirty, but you want to clean this ground strap plate around the outside. You want to clean the fin. This is what's measuring moisture. The round probe is what's measuring grain temperature. And then you also want to clean on this area where it contacts and goes into the dryer, so we have a good ground connection. Important to get that done. We'll get that back reinstalled. And then basically the way it works is there's a linear actuator here that opens and closes a gate below the moisture sensor. So there's about a 4x4 inch box inside that makes a cavity of grain. And the actuator in the bottom closes the gate on the bottom of that and allows it to catch and hold grain, where then the moisture sensor can look at it and take a sample. You need to make sure that this gate moves freely and that it'll open and close. This will run either once a minute or once every 2 minutes when the unload rotor is running. So we turn the unload on, we should see this start to move. There is a target on here and a proximity switch that just verifies that the gate is opening and closing, and the PLC or the control system needs to see that proximity switch. The gap between the prox switch and the target needs to be about a credit card's width, or about 1/8 of an inch to work properly. Okay, on the other side of the moisture sensor, there's a place where you can take a sample of grain coming out of the discharge of the dryer. And there's just this gate here. You can just remove that. You'll have grain falling all around. You want to reach in there, grab a sample. There should be a safety grate in there. Just be careful in case that grate's not installed and the conveyor is close. You don't want to get hands or fingers too low in there, but this is where you take a sample of the grain coming out of the bottom of the dryer. Okay, inside the power box, there's two doors, a left-hand door and the right-hand door. So the left-hand door is going to be low voltage and control voltage on this side. So we have 28 volt DC is the majority of it, and we have a little bit of 110 volt AC. So let's explain what these components are. We'll start at the top. We have some remote displays. The first one is going to be for the unload VFD. So that's going to show either hertz or amps, whatever we have it set at. And then we have 3 displays for the fan soft starts on there. So we can see these without having to get into the high voltage component on the right side. Next, we've got 3 air switches, and newer models might actually have a TAN style air switch right below that and actually use 2 air switches per fan. But these basically verify that the fans are on. These lines are going to run, they're going to turn into a copper line and run to the inlet venturis of the fan, and they basically just sense vacuum. When they sense vacuum, it knows the fan is on, and it's then safe to start a heater. Coming down, we have just an Ethernet switch, and it's just a simple Cat 5, Cat 6 Ethernet switch. And then this is a PLC, a programmable logic controller. And the PLC is really the main brain of the dryer. So all the inputs and outputs come into the PLC. The PLC operates on 28 volt DC power. So low voltage safe. This is the power supply that gives power to the PLC and most of the safety circuits on the dryer. So we have 110 volts coming in, 28 volts DC coming out. Over here we have RTD transmitters. So what these do, we have RTD sensors. RTD is resistive temperature device, so just think of it as a thermometer. And there's one in the plenum that tells the PLC how hot it is in the plenum. There's also one for the grain columns to tell it how hot the grain is. Those RTDs work off of change in resistance or change in ohms, and the PLC needs to see a change in voltage. So these transmitters translate resistance or ohms into voltage is what their function is. Just keep coming down. We've got terminals here, and then these are relays. And so I mentioned the PLC works off of 28 volts DC. Well, if the PLC wants to start a fan, that's going to need a 110 volt signal. And what these relays do is translate 28 volt DC into 110. And there's a number of them for the fans, for the unload, for the auxiliary load and unload equipment, and the heater as well. Come down a little lower, we've got some more relays, some circuit breakers. Just note up is on, so you want all those breakers in the up and on position. This is a Siemens burner controller. This one is an LME69 series. We're also using LME71 series controllers now. There is a light on these, and the light means some different things. If it's red, it means it's in a lockout condition. When the burner is lighting or going through a purge cycle, you'll see it in a yellow position. When it's actually in the lighting cycle, it'll be blinking yellow. If it does sense flame, it'll turn red. So there is sometimes at startup, it may not light the first time, and if this does fault out and it'll be red on here, you need to press and hold this button for 1 second. Don't press it longer than that, or you can get into a diagnostic mode, which we don't want to be. If we just press it for a second, the red light should go out, and then we can retry to fire our heater. We also have an hour meter that just measures hours of the fans or of the blowers in the dryer. So this is the right-hand side of the power cabinet, and this is going to be the high voltage or the more dangerous side of the cabinet. So just to point out what the components are, what they do, we have a main switch, so all the main power will come into the bottom of that main switch. And keep in mind that even with the main switch off, you usually are going to have live power coming in the bottom unless it's been locked out coming into the dryer. So just be aware of that safety situation. From the main switch, we'll come up to a power distribution block. It does just that. It distributes power to all the different motors and components of the dryer. Up on the top here is an ignition transformer. That is simply spark ignition to give power to the spark plug or the igniter when we go to light the burner. You'll see we have, in this case, this is a 3-fan tower dryer, so there are 3 soft starts. Ahead of that, we have 3 breakers, and if there was ever a problem, the touchscreen would tell you if there was an overload on one of the fans, and that's going to be what that breaker is. The touchscreen would also tell you if there was a problem with the soft start. And remember, you don't have to get in this side of the cabinet to see the soft start display. We have the remote displays in the left side of the cabinet. Up here on top, we have the VFD. This is for the unload rotor, so this gives a variable speed to the unload rotor, controlling the rate of discharge of the dryer. This is the control transformer, so this is going to take our high voltage, in this case 480 volt, and knock it down to 110. And then we use 110 volts for a lot of the things on the pipe train that we talked about. That's also what gives power to the power supply that reduces 110 to 28 volts for control power. There is a circuit breaker here on the primary side of the transformer, and then we have an overload here that is actually for the VFD for the unload. And that's the components on the right-hand side. Okay, so this is an RTD, and this is an averaging RTD that would be used in the plenum. So this is how they come. Obviously, it would be unrolled. This would be in the heater section, which on a tower dryer is going to be the second door up from the bottom. And as you walk in there, it's going to be about head or shoulder high, stretched out as far around the circle as we can. And this will just give an average temperature, or really average resistance, along the entire length of this. So this is going to be the variable resistance. That is then fed into the plenum RTD transmitter on the 2-wire plug, where it's translated into a voltage, and then the voltage is fed into the PLC. Okay, this is the fill switch that's up on the roof of the tower dryer. So it would be mounted like this on the roof. Rotary fill switch here, or just a rotary switch here. This is always turning. So whenever the main power is on, we have 28 volts being generated. This rotor is always going to be turning down inside of below the roof of the dryer. And when grain comes up to it, it gets to this paddle and it stops it from turning. And that's what tells the PLC that it is full of grain. So when the grain level comes down, it goes away and this starts turning again. That tells the dryer we need grain, and it turns on the fill system of the dryer. So this is a good reason to always shut the main power switch off whenever the dryer is not being used. Otherwise, this is just sitting up there turning and turning and turning and putting more wear on the system if it's not being used. Except if it's in the winter and you plan on using the dryer soon, remember that the pipe train has some heater strips on them for the hydraulic oil. Those need to be on. So if you plan on running the dryer, it's cold out, maybe you're going to run the dryer tomorrow, then I would turn the main switch on just to make sure that those are heated up and ready to be used. And then coming down from that, on the side, second sheet down, we have the incoming moisture sensor, green moisture sensor block up there. And then just down from that, we have the upper column over temp. It's a copper tube that stretches all the way around the dryer. There's a left and a right. They basically have a junction box in the middle. If you get an upper column over temp, you can't necessarily take for granted what's left or what's right. You have to take a voltmeter up there and figure out which circuit is open. Then as we come down the dryer, we get down to the grain exchangers where the solid sheets are, kind of in the middle of the dryer. Those grain exchangers have access holes just above them before a dryer is used. It's a good idea to open all those access doors and make sure there's nothing caught in the grain exchangers. We've seen like buckets from elevators come off and get caught in there, those kind of things. Just below the grain exchangers, there should be the middle column over temp Once in a while, these are put on just above the grain exchanger. So either just above or just below the grain exchangers, you'll find the middle column over town. And again, that's copper tube going around the dryer. There's a left and a right junction box in the middle. Then as we come down the dryer, we'll see, in this case, there's one of the grain column RTD sensors. There's actually 4 of those spread out top to bottom and around the dryer, and it gives us a very good average of all the grain temperature inside the dryer. This will be displayed as column temp on the touchscreen. As we come down the dryer into the cooling section, we'll see the screens change color a little bit. We see some of the free air openings. We'll have a free air opening in front of each motor. It helps keep them cool as it's drawing air in. And then we have louvered doors down in the bottom. And those louvered doors can be adjusted open or close, and that's what adjusts grain temperature. So if you want grain as cool as possible, then you close those louvers and force all the air to go through the screens and cool the grain. If you want the grain a little bit warmer, you can open those louvers up a little bit and give the fan some free air that doesn't have to pull through the grain column. And then as we get to the very bottom, there's more clean out doors in the very bottom solid perf sheet to help you clean out that unload rotor. And then there's also a set of doors on the bottom of the dryer looking up from underneath to help with clean out as well. Okay, this is the unload rotor area of the dryer, and this is where grain spills out from the grain columns into the unload chamber. And there are adjustable gates up here that control how much grain is allowed to flow onto the floor or onto the table. And then as the rotor turns, what we want to make sure is the rotor sweep arms are full of grain, not just boiling over the top, because that will usually cause too many amps and the motor to trip. We want to get the right amount of grain in there, and sometimes you have to adjust the flow gates up or down. So this is looking up at one of the blowers in the dryer, and you can see we need to check belt tension and adjust that yearly. You need to just make sure, whether it's a pivoting motor mount or 4 threaded rods, that the motor's pulleys are parallel to the blower pulleys is important. Check belt tension, there's specs for that in the manual. And there's also 2 grease zerk tube lines that should be greased for the lower and the upper bearings of the blowers themselves. The amount and kind or type of grease is specified in the manual as well. Okay, so this is inside the cooling chamber of the dryer, and there's going to be some louvered doors or louvered windows like this. And these louvers can be used to set the grain temperature. So the more open we put the louvers, the more free air we allow to come in directly to the fans and not go through the grain column, so the grain will be warmer. The more we close these up, the more we're forcing all the air to go through the grain columns, and that will cool the grain more, make the grain cooler.